Assalamu alaikum. Can you hear me? Hello. Can you hear me? Okay, just waiting 1 minute, then we'll start. Okay, so we'll start this session. So basically, today is our fifth number test, and I hope already all of you get the previous material and also get the assignment for our previous classes. Okay. So basically, today's session I discuss about that air quality monitoring. So how we can easily monitor the air quality, different types of air pollutants such as nitrogen dioxide, sulfur dioxide, or methane, as a or PM 2.5 or PM 10. So this type of things how we can easily monitor step by step. I'll try to guide you. Okay, so let me share my screen. And after completing the 3 hours live training, then we talk about our previous classes problem solving for 1 hour. So let me share my screen. Can you see my screen? Is it visible? Can you see my screen? Okay, so let's go. Okay, so basically I discuss about that air quality monitoring. So all parameters, okay, suppose nitrogen dioxide, sulfur dioxide, or methane, or aerosol, as well as how we can easily monitor the PM 2.5. So this type of things we will also try to explain step by step. And how to download the air quality parameters time series data in CSV file. Not only for that, any data set, when you download the CSV file, suppose we already know about the time series chart is not work when it across the limit. Okay, so that's the reason we also need to learn about that, how to download the data without creating the time series chart. We simply download the data as a CSV file, and further we can make the chart using Excel file. Okay, and also discuss about that air quality monitoring time series chart. We also discuss. Okay, and also how to calculate the total emission of any specific gases for any specific region. Suppose in Bangladesh 2025, the month of January, how much nitrogen dioxide gas is emitted. So this type of things we also computed, and also discuss about that AOD, aerosol optical depth, okay, as well as particulate matter 2.5, how we can easily monitor, as well as we also discuss about the ArcGIS, mainly ArcMap tool, how we can easily use and make the research paper map Google Earth Engine. Okay, export the data from Google Earth Engine, how we can easily work with ArcMap to create the map layout for our research paper or presentation. So this thing I also try to explain. as well as accuracy assessment of your air quality monitoring. So how we can easily check the accuracy, as well as how to extract the point pixel value for a specific geolocation. Suppose you have some geolocation, or you have some coordinate, mainly latitude, longitude for any specific area or point. You have some point for a specific geolocation. So now you want to extract the values, okay, pixel value. It can be different types of pixel value, suppose air quality monitoring or ndvia or anything, okay, because this type of things further we also need to work with, compare with our ground truth data and also satellite data. Suppose I have some data, ground truth data, I have some ground truth data for a specific point or a specific location. I have some data, suppose nitrogen dioxide data, or suppose pm 2.5 data. I have some data, ground data. So I simply visit my ground and I take some data for a specific geolocation. So this geolocation I want to import in my Google Earth engine, and further I want to compare the result on my ground data and also satellite data. So further we can easily compute the different types of metrics, such as root mean square error or r square. Then we find out the correlation. Okay, so this type of thing, for that we need to extract the point pixel value for a specific geolocation. Okay, suppose I have 100 point. So this 100 point I want to extract the nitrogen dioxide value. Okay, and further you just compare this value with my ground data different way. Suppose root mean square error or r square, different types of metrics we are used, and we can easily identify. And also discuss about the trend analysis. Okay, suppose for a specific study area, what's the trend for air quality? Not only for the air quality trend, we can easily check different types of trend. Suppose what's the trend for vegetation, what's the trend for air quality monitoring, what's the trend for water. So different types of things. What's the trend for precipitation or rainfall? So any time series data, we can easily check the trend. Suppose I have a data, suppose I have 1 year's data, or I have suppose 20 years data. So from this 20 years data, I can easily check the trend, and I can easily take the decision using the trend. So it's the day by day increasing or day by day decreasing. So this type of things we also discuss in this session also, how we can easily monitor the trend. Suppose air quality trend or also vegetation trend, same process you can apply, and you can easily check this type of trend. And how to apply the linear regression model. Suppose I have some ground truth data, so this data I want to use, and further I want to use the linear regression y equal to mx plus c, and then I can easily predict different types of variables. So I will explain all of those step by step, then you can easily get the idea. So first of all, we discuss about the air quality monitoring using remote sensing. So in this time, so let me open my code editor. So there's a lot of sensor or lot of satellite image we are use for monitoring air quality. Okay, and there's a lot of advantage to use the remote sensing for air quality, because wide coverage. Okay, suppose satellite provide the regional to global view. Okay, suppose ground station which are point based, but in this time we find out the satellite, it provide the regional to global view. So basically we find out the ground station data. Suppose I have a specific ground or point, then this type of ground station which are point based, only for the point based. But in this case, when you are using the satellite data, so it provide the regional to global view. We can easily identify. Suppose for whole Bangladesh, I want to identify the nitrogen dioxide density, I want to identify. So it also possible. Suppose you have some ground truth data point based. Suppose you have some ground station, so from this ground station I can get the data point based. But when I use the remote sensing, it provide me the data regional to global view. I can easily find out the global view or any specific region. Okay, so this is the one kind of cover benefit to use it, as well as long-term monitoring. Okay, so I'll also write this type of benefit, then it will also help you for reading. Suppose benefits to use the satellite data. So first one, we can say that it's a wide coverage. Suppose we can easily find out that global to regional to global view, we can easily identify. as well. And finally, second, we can say that it also long-term monitoring. Okay, long-term monitoring. Suppose satellite have some archive data. Suppose we can easily identify in year of 2018, okay, or 2019-15. So near real time as well as also very past time, we can easily long-term monitoring using this satellite data, as well as also many data set we are use. Okay, suppose we can use at the Sentinel. We also use some Moody's data, okay, to monitor the air quality monitoring, as well as we can also use at the basically from, okay, so basically from the Moody's we can find out the AOD information. And what is the AOD? AOD basically aerosol optical depth. Okay, aerosol optical depth, basically dust. We can easily get this type of information, aerosol optical depth, as well as we also get the another information, it called the fire emission we can also detect using the Moody's sensor, TEDA or EQUA, both of this. And then Sentinel, from the Sentinel 5P, this is that another satellite. So from this satellite we can easily access suppose NO2, nitrogen dioxide. We can easily get the SO2, sulfur dioxide, then CO, okay, carbon monoxide, or O3, ozone, okay, O3, as well as so methane, CH4. Okay, so it provided all formaldehyde. So it provided a lot of information for air quality. We can also find out, as well as we also get the another sensor. It's called that OMI. Okay, OMI. So this data catalog is not available in the Google Earth Engine catalog. It's not available, this data, but we also download the data from NASA website. Okay, so this data should also download from that NASA website and also use it. Okay, no problem. As well as another sensor we also use. It's called the what's wrong? So let me check just a minute. AUR. Okay, this one, yeah. This is the website. So from this we also get the some air quality data from this satellite. Data resources, let me check. Data processing, external data source. You can see different types of data. So sulfur dioxide, if you check, just click on here. So now it open the sulfur dioxide website. Okay, from this website we can easily download the image or GOT file format data. We can easily download, as well as you can see the ozone. So further you also try to explore this type of link and further try to download the data. So you can easily find out. So it shows this type of thing. Suppose which region you want to need. So we can easily select the specific region. You can see this is the region. So you find out, you can see this type of region. So which region you have need, simply download from here. Suppose any, you can see I suppose Asia or Central Asia, you can see. Suppose click on the Central Asia, and you can see which date you want to need or which month. Suppose I need the data for January, and put the year. Suppose I put the year 2023 and then submit. So now it automatically show you this result for the Central Asia sulfur dioxide in year of 2024 month of January. Will it show the not found? Why? I don't know. Okay, so we try to explore later this type of things. As well as we also use some aerosol data. Suppose I have aerosol data or AOD data. So this AOD data I can easily convert using PM 2.5 or also PM10. So I can easily convert AOD. Suppose I have AOD data, then I can easily create the PM 2.5, okay, or PM10. This type of thing we can easily monitor. So just click on here and open the Sentinel. So if you check the data set Sentinel 5P, and if you check, we find out all of data set for Sentinel 5, we can easily get aerosol index or cloud, carbon monoxide, formaldehyde, then nitrogen dioxide, then ozone, then sulfur dioxide, then methane. Okay, so this type of data is globally available, we can easily use. And this type of data we find out, you can see near real time and offline, near real time and offline. So near real time, it provides with the more update data. Okay, if you check for the near real time, just click on here. So it shows the more update data. So it's available 25 5 September. Okay, 5th September. Okay, today days we also find out this data. Okay, so it provides the near real time. Okay, near real time data. Another data set, if you check, it shows the offline data. It's not the near real time. So it shows the data 26. Okay, August, 26 August, we find out the data. Sometime we need to use the near real time when you monitor for the near real time scenario for air quality pollution, then we try to use it. Or we can also use there, no problem. Okay, so different type, both are the same process when you're working. Okay, both are the same process. And you can see what is the temporal, we find out the 2 days. Okay, temporal resolution 2 days, revisit frequency. And this is the data set. Suppose I want to use the data, so you can see this is the earth engine snippet, as well as if you check, this is the pixel size of this data. And we find out, you can see this is the first column, it's called the nitrogen column number density, and this unit is the mole per meter square. Okay, mole per meter square. And also you can see this is the another column, it's called the tropospheric, this is the another phase or atmosphere, tropospheric nitrogen column number density, then stratospheric. Okay, so I want to compute the density. Okay, where is the high density of nitrogen dioxide, where is the low density. So that's why I just simply use this band, nitrogen column number density, and this unit is the mole per meter square. So first of all, you need to simply copy this snippet ID and paste here, and then this thing simply store it in a variable. You can put any variable name. So I put the variable name, suppose data set. Okay, so this data set, I simply store it, this variable is stored, this image collection. So now this image collection I want to filter. Okay, we already know about that, how we can easily filter this image collection. So first of all, simply put here that filter bounds is intersecting with your image with your study area or your shape file. Okay, so you can simply import your study area. Suppose I choose so I choose this Dhaka as a study area, and I put the name as a ROI. Okay, so now filter bounds with ROI, and I want to monitor a specific time period. So I put the filter date. Filter date, I put the time, suppose year of 2025. Okay, 0801. Okay, then year of 2025, suppose 0831. Or what is that last time period? If you check, last time period is for, it's a offline, it's a 0826. So I put here the 0826. Okay, but we also use the near real time data set and check the more update data also. Okay, so just need to change the image collection, so it's the offline, but another data set is the near real time, so you can simply apply the near real time, copy the snippet id, and also take the more update time to check the air quality or nitrogen dioxide density. So I put this type of things, and further I want to check how many, and I also select, suppose I select the specific band, which band I want to work. So in this case I want to work this specific band, nitrogen column number density. This band I want to work, so just copy and paste here. So now let's check how many images are available in this collection. So same process, just use the print function and call the data set, use the size function to computing how many images are available in. So we find out the 353 images for this time we find out. So now first of all I discuss about the time series chart. Suppose I want to create the time series chart for this using this image collection. So we already know about that. We need to use a function, this function called the, if you simply search here, ui.chart ui.chart.image.series. So this is the function we need to use to create the time series chart. Series. Okay, just paste here. So now we find out, you can see first of all is the image collection. So I already compute the image collection, so just I copy this variable, because this variable is stored the total number of image collection, just I paste here. And now region, it's your shapefile variable name, which is RY. So now I want to compute, suppose average density of nitrogen dioxide emission, just put here e dot reducer dot mean. Then scale is the resolution of your satellite images, so basically this is the resolution or pixel size, just copy, use it, and then further just use, suppose X property, system time start, default system time start. So now whole thing simply store it in a variable, suppose chart, and then print the chart. So print chart and run the code. We find out this type of time series chart, and if you check, we face a problem. This problem is that it show the 0. You can see we find out the 0 0 0 0 0, but it have a value. Okay, but this value is not showing, it show the round figure as a 0. So this is the common problem, because in this time, this type of value, suppose in this time August 1 or 1st August, I find out a value, this value is the very close to the 0. Okay, suppose 3 point inverse 10 inverse 4. Okay, very near to the 0. So that's the region when I create the chart, it show the round figure and display the value as a 0. Okay, but it has also value, but this value is very close to the 0. Okay, or very less value we find out. Okay, so in this case, what is my unit? My unit is the mole per meter square. Okay, mole per meter square. Okay, but when I compute using the mole per meter square, so this value is very less when I compute using the mole. So that's the region, it show the 0 figure or show the round figure as a 0, but it has a value. So now we can simply take the more lower unit, suppose mole. So I just simply convert micromole. Okay, so when I convert this unit into micromole, then I find out the value. in micromole unit. Otherwise, if I keep the mole unit and this value is very less value, and Google Earth Engine chart, it displays as a round figure 0. So that's the reason when you face this type of problem, for the basically face this problem for the air quality different types of data. Okay, so when you face this type of problem, then you try to change the unit. Okay, otherwise you can see all of value show as a 0. Okay, and when you download the CSV file, you can also find out the 0. Okay, but this type of chart have a value. Okay, and this value is very less value when I compute using mole per meter square unit. So that now we just take the more lower unit, micromole. Okay, so we try to convert this data set we try to convert into micromole, then we try to chart again, and then we find out the value. So let's go try to convert mole to micromole. So if you simply search here mole to micromole, so if you check the 1 mole equal to this value. Okay, so this value you need to multiply the amount of the substance. Okay, so this value I need to multiply. Okay, so when I multiply this value with my mole result, then it will be convert into micromole unit. So now this value I need to multiply. So I need to multiply with my all of images, 353 images. So for that, what can I do? If I just, you can see, if I just put the multiply and run the code, it show a problem. Okay, we face this type of problem. So now how I can multiply all of images, this value, how I can multiply this value with all of images. So for that, we just create a tool or create a function. So I create a function. This function help me to compute or multiply this value with all of images. Okay, so let's go try to create a function. So for that, just take a variable. Suppose I put the variable name is that micromole data set. You can put any name. So now create a function keyword and put the element name, suppose img. You can put any name as element. So this element I want to return and multiply this value. Okay, we already use a lot of time this type of function, and this same things I want to copy all properties. So put here the copy properties, this element, and these things apply system time start to system time end, start to system time end. So now I create a function. Okay, so now this function one by one, suppose first image input in this function and multiply, then second image input, third image input, and up to 353 images one by one, all of image input in this function, and compute this, multiply this with this value. So now these things I want to connect with my collection. So for this, just copy and paste, and connecting, for the connecting use the map function. So put here the map, close the bracket, start the bracket, close the bracket. So now this data set, it is stored total 353 images. So one by one image just come in this function and multiply with this value. So now we try to compute this, and if you check how many images after multiply, we find out the same number of images. Just we simply multiply with this value because I want to convert the unit mole to micromole, same number of image collection. Okay, so now I want to use this micromole dataset and create this time series chart. And if you check, we find out the value. So you can see first August 88.539 micromole we find out. Then you can see all of those show the value, and when we find out the highest is show the result 138.745 micromole we find out. Okay, and if you check, all of data is now available, and now this unit is the micromole unit. But first time when you compute mole per meter square, we face a problem. It show the zero. Okay, round figure show the zero. Okay, so now suppose okay, so I will show this example. Suppose I have this type of time series chart. So basically, when you work with better trend analysis, we need to take the more than 10 years or 5 years data or 20 years data, because when you add the more data set, your trend analysis will be more perfect or more accurate. Okay, but we can also apply the trend analysis also this data set, no problem. But when you work in your real project, you try to add the more data set. Okay, so let's go. I want to check the trend. Okay, so I want to add the trend line, and further from here I want to check what is the trend for nitrogen dioxide in Dhaka city. It's day by day increasing or decreasing. Okay, so these same things you can also apply for the precipitation. Suppose you just make the rainfall time series chart, and further you check what's the trend for rainfall or what's the trend for precipitation. Same process for NDVI. Suppose you just make the NDVI time series chart, and now you want to check what's the trend of NDVI for vegetation or water body. So different way we are use the trend analysis. This same thing we also try to apply for the air quality. Suppose based on the data, I want to check what's the trend for your air nitrogen dioxide. Okay, so for that we simply add some option. So first of all, I simply add some option. Suppose chart title, X level, Y level title. So put here suppose set options. So add some option on your chart. First of all, title. So I am to add the title. Put the title, suppose NO2 time series. You can put any title. Suppose 2025. Anything you can put. And then further I want to apply suppose Y level, mainly vertical axis, so V axis, and put the title. And put the title, suppose it show the result micromole per meter square. Just put the unit, suppose micromole per meter square, or you can also put the symbol micromole per meter square symbol. Then horizontal axis, so this thing in this I put here, so it's a time or day, suppose day. Okay, so now put the title. Yeah, so now run the code. So now this type of things will be added. Okay, now we find out this type of chart. But first time without this type of option, we find out the continua chart. But when I add this type of title, Y level, X level title, then we find out this type of a dotted chart. Okay, so now how I can make the continua chart? So it also possible, you can also create the continua chart. So it's called the line breaking chart. Okay, or discontinuous chart. So when you face this type of problem, not only for this data, any other data set, when you face this type of line breaking chart, then you try to add the another argument. It called the interpolate nulls. So put here interpolate nulls. Just open for open. Just use the boolean operator true. So now if I run the code using the interpolate nulls, then we find out the continuous chart again. So now you can see find out the continuous chart, and the chart is also added this type of Y level, X level, and also title. We can find out. We find out this type of chart. Okay, so this is the one way. So when you face this type of line breaking chart, try to apply the interpolate nulls. Just open using the true, then it will be work. Yeah. So now I want to check the trend line. Suppose how I can add the trend. So for that, just take the another keyword, suppose trend lines. Okay, trend lines. So now in these trend lines, basically we find out only for the one line, you can see. So it's only for the one line. Sometimes we also create the combo chart. Suppose at the same time we can add the different combo chart. Okay, it also possible to create the combo chart. Suppose for the different location, create the different chart. So I also discuss after some time. Suppose this line show for the Dhaka city. Suppose I create the another line, it show for suppose Gazipur, it show the result for another chart, it show the result for Rajshahi. So different location we can set this type of line chart. Okay, then we can easily comparison between Dhaka to Rajshahi, when it will be high, when it will be low. We can easily compare using this type of chart, using the line graph chart. Okay, suppose Dhaka city, Rajshahi, Rangpur, so all of specific region, I simply take and then I create this type of chart. Suppose this line represent the Dhaka city, another line represent the another city. Okay, the results compared. So in this case we find out only for the one line, and this one we represent as a 0. Okay, 0 refers to the first item and there is no other item, so I put the 0 means that it's a first column. I just choose only for this first. Suppose you add the more other line, suppose this there is another city time series. Okay, then we find out the 0 and 1. This is the 0, this is the another for 1. Suppose this we have the another, suppose then 3. So now which line you want to use and make the trend line? Suppose I want to use the 0. 0 refers to the first line, 1 second, 2 third. So I create this first line for the trend. So for that I put here the 0. So now after the 0 we set the type. So put here the type. So there are the different types of trend line. Suppose linear, polynomial, or exponential. Okay, different types of trend we can also use. For the linear, then polynomial, or also we can use here the exponential. So I want to apply suppose linear. So I create the linear trend line. So put here the linear. Okay, and if I run the code, so now it added a, because we find out this type of linear line. Okay, it show day by day increase. We find out that it's a upper trend. Okay, it means that for this study area, day by day nitrogen dioxide concentration or density is increased because it's the upper trend we find out. Okay, so further we also add the different types of style of this trend line. Suppose you want to add here the line color. Suppose just put here the color. Suppose I put the color is the red and on the code. So now it display the result that the trend line show as a red color. You can see. Okay. As well as if you want, you can also add here that you can also increase the line width. So for that, just put here the line width. Suppose I put here the line width is that 8 pixel. So now run the code. So now it also increase the width. Okay, I can see. As well as if you want, you can also add here that opacity. Suppose I put the opacity. So I decrease the visibility of this line. So for I put here suppose 0.2. So now you can see it also decrease the visibility. So you can see find out this type of line. Okay, if you want, you can also add here the legend. You can see. So now it show only for the only for this column number density. It show the legend, but I want to add the legend for this trend line. So for that, you can also add here the another argument. It's called visible in legend. Okay, then just put the true and run the code. So now it also added the legend for the, you can see it added the two legend. You can easily identify from here. So this is the way we can compute the trend. Okay, so using our time series. Suppose I have the 10 years data or 20 years data. So based on the data, I just create the trend. So from this trend, we can easily get the upper trend or lower trend. So upper trend means that day by day increasing the pollution level of nitrogen dioxide. Lower trend means that day by day decreasing the pollution. Okay. So this is the way we can use and we can compute the trend analysis and also add the trend line in our time series chart. Okay. Okay. Anyone in question? You can ask me, please. Yeah. Any question? Okay. 2 decades with seasonal variation. So okay. So data set. Okay. So who is data?
Sir, suppose
Yeah.
you have taken Dhaka city as a study area. So, how many points you have that calculate the air quality analysis? Yeah, whether this data for overall the study area or
It's
there
overall the
there
study
may be
area.
some points
Okay. So in,
overall the.
yeah. So in this time, okay. So let me show you the map also. Then you can get the idea. So in this time, it show the suppose in the first suppose August we find out the value, and this value show the whole city. Suppose whole Dhaka city average density. Okay, this value. This
So
yeah
in the Dhaka city, there may be variation, spatial variation in different parts. Will have different air quality.
yeah.
So how can calculate that?
So these things we also display. Suppose a special variation. Suppose this place have the high density, this place have the low density, this place is the middle density. So these things we can also visualize in our map. But now it show the average. Suppose average in the first August, what the average density? Okay. Then what is the in the 4th August? What the average density for the whole study area? Okay, for the whole study area. Okay, for our this whole study area, we can compute. Okay, average. Okay, for the every single day, what the average? If you want, you can also compute. Suppose what is the maximum concentration for every single day. We try to check it. So for that, you can simply add here the max. So now it compute the chart for maximum concentration of nitrogen dioxide for every single day. Okay, so now this result show for the maximum density. Okay, maximum density for every single, so you can see for the first August I find out. Okay, let me just, so we find out, you can see this type of value 100.453 micromole. Okay, this is the maximum in emission of nitrogen dioxide. Then you can see the 4th August we find out the 134.4 micromole density. Suppose you want to check for minimum, then put at the mean, then it show the mean. So I want to check the mean and max. So now at the same time we just create, you can see two chart. So you can see we find out the in the August, this is the maximum. What is the maximum concentration? 100.453. And what is the minimum? We find out the 72.158. So then if you check all of those, so you can see we find out the maximum concentration of nitrogen dioxide in 17 August. And what is the minimum? Minimum we find out the 105.277 micromole. Okay, and we create the time series chart. Okay, for the first zero indicating about the first. So then you can simply download the data also from here. Okay, so it show the min max function when I apply. So at the same time, suppose in the first August, what is the maximum value, what is the minimum value, I can easily find out from here for concentration of nitrogen dioxide. Not only for that, any other data set you can also apply the min max function. It help you to compute at the same time for a single day what is the maximum concentration, what is the maximum ndvi or minimum ndvi. So this, or maximum temperature or minimum temperature, maximum rainfall, minimum rainfall, you can easily identify from here. Okay, so now I want to display the spatial variation, then we can easily get the idea which area is the high concentration of nitrogen dioxide, which area is the low concentration or medium. Then this type of things we can easily get the idea from the map. So let's go try to display the map. Okay, so for the map, just take a variable. Suppose I want to compute the average density of nitrogen dioxide using the micromole dataset. Okay, I already make the micromole dataset. Just I copy and paste here. So I compute the average, put the mean, and then clip with my study area, which is ROI. Okay. So now we try to display the layer of mean NO2 to check the spatial variation and also focus on our given study area. ROI, you will be 10 and run the code. Okay, let me add the color. So there already provide some demo color code. Just let me copy. I just paste here and change the mean and max range, so we can easily check it from here. Just keep stressing the level, so 98% I keep, and now it show the mean and max range. Just I copy and paste, and also copy and paste for better visualization. Just copy the color and then paste here this visualization parameter. I put the NO2 and run the code. So you can see we find out this type of data. Okay, and this data it look like that. Okay, suppose you can see we find out the grid or cell. You can see it's a grid or cell because this pixel size is 1113.2 meters. Okay, so that's why you find out this type of grid or cell. And now if you check and also compare the color, if you check which area you find out the high, so red color indicating about the high, okay, and black color is indicating about the low emission of nitrogen dioxide. So basically we find out this type of high emission of nitrogen dioxide, this type of place we find out the high emission of nitrogen dioxide. And if you check this type of place, black color, and also you can see then blue color, okay, so this type of place we find out the low, it gradually increased, so we find out the high. You can see then yellow, this type of pixel is also indicating the high, also this type of green, and lower black is show the lower and blue is lower, and then gradually increase this type of color. So further you can also download this map and also work with ArcMap to create the classification. Suppose I create the very high, then high, low, moderate, very low, then low, so we can easily create this type of classes and also identify for a special distribution. So in this case it look like that because it is a small study area, but I want to apply the 1132 point very high pixel size data set. But when we apply this data for the big study area, suppose I just take the data set for whole Bangladesh, then check what happened. For the whole Bangladesh, I am to identify for nitrogen dioxide density for this time. So further simply import your shape file for Bangladesh boundary. So just I import this Bangladesh boundary shape file, and I put it, so it says suppose I put suppose BD, and further I simply just click with BD, as well as also filter bounds with BD, and then we are just make the time series chart for BD. Okay, so now this result is loaded for the whole country boundary of Bangladesh. So now run the code. So now find out that for that whole country boundary of Bangladesh, nitrogen dioxide density in August, 1st January to 26th August, and we can easily identify where is the high, where is the low. We can easily get the idea. Okay, so it look like that. So let me stress the level and try to show you the result. So just click on here Okay, let me stressing suppose 98%. Okay. Just copy and paste. And paste. So now run the code. Right. So now we find out that is smooth map, but for the small we find the very you can see. So now we find out this type of map in the August, 1st August to 26th August. This is the special distribution. So we find out mangrove area or coastal area. We find out the low concentration of the nitrogen dioxide, but we can find out you can see this type of place or city or Dhaka city find out the high concentration, and this result only for that your 26 days. Okay, 1st August to 26th August. Okay, we find out, and if you check the value, suppose just click on here and then suppose just click, so you find out suppose 108 point something for this coordinate. Okay, micromole. So we're going to check this type of place. So for this type of place we find out the low, we can find the 53 point something. Okay, so this is the special variation or special distribution. We can easily identify which area have the high concentration of nitrogen dioxide, which area has the low concentration of nitrogen dioxide. We can easily get the idea from here. Okay, so now I want to apply, suppose I create the time series chart for the different point. Suppose I just click on here and I take this point. Suppose I click on the features. Okay, just a minute. Okay, suppose I have some coordinate. Okay, coordinate basically latitude and longitude value. So this type of coordinate I want to use, and further I want to make the chart. Suppose I have a coordinate for the Dhaka city. I have a coordinate suppose for Rangpur city or Rajshahi city or any other specific city. So now I want to use this type of coordinate, and further I want to make the analysis. Okay. So further we simply define our this type of coordinate. So I simply show you that um, time series chart for suppose different regions. Okay, so for that we can simply okay, so I simply search here, suppose Dhaka city lat long, simply search. So now it provide a point. Suppose this is my longitude and latitude value for Dhaka city, so I want to use it. Okay, so for that create a feature. Okay, we all know about that how we can easily create a feature. So just take a variable, suppose, and create the feature. So put here ee dot feature. Okay, and I want to create the feature using the point, using this coordinate. Suppose this is my longitude and latitude. So for that we simply apply the another function to create the point feature. So I already discussed this type of things for our previous classes, how we can easily create the geometry, or how we can easily create the feature or feature collection. Okay, and what is the geometry, what is the feature, and what is the feature collection. So we try to apply suppose geometry dot point. This function we try to apply and create the point for our study area. Geometry multi point. Yeah, so this function I need to apply, you can see e dot geometry dot point and apply the coordinate, basically latitude and longitude value. So if you check what is the coordinate basically you can see a list of 2x and y coordinate in the given projection. So list, we find out the longitude and latitude. Okay, so we try to apply this function, just I copy and create the point, create a point for this coordinate. Just I make a list and define x and y. Okay, suppose let me add, for this is the result for longitude, and paste here, and this is the result for latitude. Just I copy and paste here, and I put the projection default, not need to change. So I create a feature. Okay, let me check it's the properly work or not. So let me add the layer and check it. For first one, I just simply add the layer of my point and display. Yeah, so it's properly work. You can see we find out this coordinate. So I want to add the more coordinate, and I also put the label. Suppose I set the label for that. So just put the comma sign and create a dictionary. Okay, I set the label, or you can put the name, no problem. I put the name. Suppose name, I put the name is Dhaka or Dhaka city point. Okay, suppose I create the one feature. Okay, this type of feature I simply create one feature. Suppose I take the another point for another city. Suppose I put here another city point, suppose Rangpur city lat, simply search. Then you can easily find out this is the longitude, this is latitude. Basically this type of things we can collect when you visit our field. So simply we visit our field and use the your coordinate trackers tool. Okay, so this tool we are use and take this type of coordinate. Okay, so where I collect my ground truth data. Okay, suppose I simply visit my field and I take some ground truth data, suppose for PM 2.5. Okay, so where I find out this type of data, so I take the training point, basically latitude longitude value, and also mention the ground truth data, suppose PM 2.5, NO2. So this type of data we simply store it, and there's a lot of process for data collection. So how we can easily collect the data from the field. So we also use this tool, Kobo toolbox, okay, to collecting the data. Okay, so you can also try to use this data when you work with the field. So Kobo toolbox, it's provide you the very we can easily get the data, all of data we can easily put in here. Okay, suppose latitude longitude and what is the value. Okay, further we can easily download the CSV file from here, and this type of CSV file we can easily use in the Google Earth engine. Okay, so Kobo toolbox is very powerful for the collection management and visualization platform used the globally. So you also try to use the Kobo toolbox. Okay, in your mobile app. It also mobile app is also available, and collect the data. The data basically, suppose this type of longitude latitude data, and also for your ground truth data. Okay, for the ground truth we also use the another measurement tool for the different analysis. but for the managing or also storing, it also help you for the Kobo toolbox. So now you want to create the another feature for this. So for that, just I copy the same line of code and paste here. So I create the another feature for that. This is the longitude and paste here. Suppose this is my ground truth. I visit this point and take the data, some data. Okay, and also suppose this is the latitude. And I put the name, suppose it's a wrong put. So I take the another one. Suppose Rajshahi city that long. We simply take this. So basically, we try to compare the air quality monitoring for the different cities and identify which cities is more polluted, which city is the less polluted. We try to identify. Just I take this coordinate and okay, just take the same line of code and paste here. Then copy this longitude value and paste, and also call that latitude value. And paste. So I put it's a Rajshahi. Okay. So suppose I take that's finally last one I take for suppose another suppose Rangamati. So I take this for Rangamati. So let's go try to use the same. Oh, just copy and further paste here and put the latitude longitude value. So this is the longitude and paste. This is the latitude value. Copy and paste, and I put it say. Okay, suppose I have this type of uh, point, so I simply add and also add their attribute. Okay, so now these things I want to convert as a feature collection. So basically just all of feature I combine and create the feature collection. So for that just apply a function dot feature collection function to combine all of those. So just apply here dot feature collection. Okay, and we just bracket start. Okay, and also close this bracket. Okay, and also make the square bracket for creating the list, and then put the comma sign. This is the first, then this is the second, this is the third. Okay, what's the problem? Let me check. Oh, okay, so it's okay. So it's okay. So now we try to visualize all of regions in our map. Okay, if you check, we find out, okay, Dhaka, Rajshahi, Rangpur, and also another Rangamati. Okay, you can also take the more point. Or we have the, so now we want to compare the analysis. Suppose for this, so how I can compare? So further we try to create the chart. Suppose for this point, for this point, for this point, and also for this point, we create the time series chart, and then we compare which area is more polluted, which area is the less polluted. We can easily identify from this time series chart. So for that, we need to use the another function. We need to compare for the different region. We need to apply the another function for time series chart. It's called the by region. Okay, so UI dot chart dot image dot series by regions. You can see by regions, by region. This function is just a import. Okay, so just UI chart image dot series by regions. So this function, first of all, image collection. So we already make the image collection. So here is my image collection. So micromole dataset. Okay, so this my image collection. It destroyed all of images. Just type paste. Then regions. Region will be more than one region or multiple regions. So I already create the multiple regions. Just call these regions and define in here. Then reducer, I know compute suppose average concentration for each region. And then put here band. So band basically it's your satellite image band. Okay, so we already have a band. So this band is called the nitrogen column number density. So this is the band I want to use, and then paste here. Then scale is the resolution of your satellite images. So this is 1113.2 meters. X property, we set the X property as a default system time start. And finally series property, so basically it show you all of suppose I'm to display all of name in my cities. So for that is, you can see the label is the keyword is the for name. This thing is stored all of name. So just I use the name as a series property. Okay, so just use here the name. So now this whole thing simply stored it in a variable, suppose chart, and then run the print the chart and run the code. So now we can easily get the result. So if you check, we can find out. You can also add the chart title, y level, x level, title later. Same process for like the chart for adding the x level, y level title. Okay, so you also try to add the letter. How we can easily add the title. So in this time, if you check the chart, so you can easily find out it's a Dhaka city graph. This is the Rangpur. This is the Rajshahi. This is the Rangamati. And if you check Rangamati, we find out that lowest concentration of nitrogen dioxide, because Ranga city is the hilly district. Okay, it's a hilly region, and the Dhaka city we find it's show the very high, because there's a lot of vehicle, there's a lot of source which provides the nitrogen dioxide gases. Okay, so that's why we find out this type it's a high. Also you can say Rangpur, this is another city. Russia you also find out, okay, this type of things, but Rangamati it show the lowest concentration of the nitrogen dioxide. level we find out. Correct. So this is the way when you compare your data with different study area, just apply the same process. Suppose you want to compare these things for the NDVI or NDWI or any other data set, just apply the same process when you compare the different region to make the time reach chart. Okay. So this is the way. You can also download the all of data. You can easily download. Okay. Anyone any question, you can ask me, please. Okay, there is no question. Okay. So let's go. So now I try to increase the time period. Suppose I put the time period, it will be start from 2018. Yeah. So now run the code and check. So now you can see it also increase our image collection. And it also takes some time, as well as we face some problem. So when you work with a lot of data set, sometimes chart is not work. It face some problem. When it across the limit 5,000 element, then chart is not working. Then you need to apply the another process to creating the time series chart. So I'll just show you that process also. Yes, please. Yeah, kindly unmute and then. Yes,
Hello.
yes, please.
Thank you, sir.
Yeah.
Sir, do we need to validate such type of data like we download from cases data from satellite? Do we need to validate any ground apparatus or any
Yes.
ground?
For the checking the accuracy, we need to compare with
Yeah.
the ground data.
So sometimes we do not have a long period of data like we 10 years or 8 years data. So how we validate it? For short, it is okay. But when we
Okay, so for
compare it
that,
for long period of time.
so then we just simply take the present data and then validate. Okay, for the long period, so this type of data set is not possible. So then we just simply skip this type of part. Or if you have some research paper, okay, who there have this type of for the same study area, then you try to use this type of data also for validation. Okay, for the previous study, suppose previous research paper, they also use this type of data to make for validation. You also try to use this type of data and also make the validation for the previous time. But near real time, we can easily collect the ground truth data and also validate our data, satellite image data. No problem.
Okay, right. Thank you.
Sir,
Yes, please.
so I have a city for study area which administratively divided into number of wards.
Yeah.
So should I analyze ward wise or should I take some points of city for air quality analysis?
Okay, so in this time you can take the city, then it will be more better because our image data set is also pixel size is also high. Okay, because this one cell have 1130.2 meters, so that's why when you try to take the big study area for this type of data. Okay, otherwise we find out only for the one cell, okay, for the one word. Okay, then it's not provide you the better map. Okay, so try to take the big study area, city or district or sub district, and try to compute it. Okay, so now you can see we face this type of problem. Okay, you can see it show the error generating chart, user memory limit exists. So we face this type of problem when it across the limit, chart is not work. But when you face this type of problem, then we need to download the data from the Google Earth Engine directly by CSV file. Okay, not need to create the chart. We simply download the data in CSV file. So let's go ahead and discuss about that, how we can easily download the data without creating the chart. But short time period we can easily get the chart, there is no problem. But when I just increase the long time period, then we face this type of problem. Okay, but we can also use the another method to download the data in CSV file, and further we can also get the data. So let's go try to discuss about that, download the data in CSV file. And this method you can easily apply for any other data set or any other image collection. So for the CSV file, okay. So in the CSV file, basically we generate, suppose column, X column, one column represents suppose time. Okay, show the time stamp. Okay, and another column show for the value. Okay, suppose this value for nitrogen dioxide value. So in the CSV file we generate, it contains the two column. One column display the time stamp for the time period. Suppose 1st January, what's the average value? 2nd January, what's the average value? 3rd January, what is the value of nitrogen dioxide? So we need the two column, time stamp column and also value column. Okay, which represent all of value. So let's go try to use. So for that we need to create a function. Okay, so let's go try to create a function. So take a variable. Suppose I put the variable name is CSV, and now I create a function. This function help me to compute every single image average value, as well as also extract the date. Suppose 1st January, what's the value? 2nd January, what's the value? 3rd January, what's the value? So I create this type of function. So for that, put here the function keyword, and put the element name img. And using the img, I need the two things. First, I just use this element and compute the value, as well as from this element I extract the date. So let's go, let's take a variable, suppose date equal, I just call the element. So from this element I extract the date. So for extract the date, use here the date function. Okay, date function, and you also define the format of the date. Suppose we can format is that year, month, and day. So this is the one kind of format. Suppose you need only for the year and month. Basically it's a date wise, so we also take the date also, no problem. So year, month and date we just consider. So from this element I just extract the date and also define the format of the date. So now another, I need to compute the value. Okay, use from this image I just compute the average value. So for that, take a variable, suppose value, and I want to compute the value from this element. Just I copy this variable and paste here. And when you compute the value, suppose maximum value, average value, or standard deviation value, so any statistical value for a specific boundary, we just apply a function. This function called reduce region. Okay, so this function need to apply when you compute any value for any specific boundary, and then check, and then put all of keyword and key value. Suppose reducer, I have to compute the average value, ee dot reducer dot mean. Then put here the geometry, which is indicating your specific boundary ry. Okay, and put here scale is 1113.2 meter. Okay, so now I create the two things. You can see date and value, okay, using this element. Okay, so after creating this date and value, so these two things we simply store it as a keyword and key value. Okay, so take a variable, suppose date, I make a dictionary, I put the keyword, suppose date, and also same for date, same process for the value, and also put here the value. Okay, so just create a dictionary. Okay, same keyword and same key value for the date and also value. So now what I return from here, so I want to return feature. So basically feature, so we already use the ee dot feature. So this function we already use. This feature have a two argument must unit. So we already use, you can see ee dot feature, ee dot feature, ee dot feature, and we define the geometry as well. Then we define the attribute. Okay, mainly your information. Okay, you can see attribute we already defined. So ee feature, it stored the geometry as well as also stored the another information for attribute of this geometry. But in this case we try to download the data not for a specific boundary, it's the whole study area. So we already defined the geometry ry. I need only for the value. I need only for the value. I don't put any kinds of coordinate or latitude, longitude, or any kind of geometry I don't mention. So put here the null and then set with this dict. Okay, so simply use this function, and this function just connect with our image collection. Then each image just input in this function and further compute the value, extract the date, and return the date and value. Okay, so further you can simply call your image collection. I want to use suppose micromole dataset. This image collection I want to use.